In this assignment, you'll be writing your first PLC program that you download to an actual PLC to control a real electrical system. This is a photo of the electrical cabinet where we have wired some push-button switches and several lights. This will be the same electrical cabinet used for some future labs as well, but this first program will be pretty simple. The function of the program should allow you to push on this blue button indicating there's a car on First Street, which should result in the First Street green light turning on as well as its associated pedestrian crossing light. And then when you release the button, those lights should turn off. When you push on this Start button, the two red lights should turn on, and when you release the button, those lights should turn off. When you push on this blue button, indicating there's a car on Main Street, then the Main Street green light should turn on, along with its associated pedestrian crossing light. And when none of the buttons are pushed, both of the yellow lights should be turned on. Here's a photo inside the electrical cabinet. You'll notice that it includes a 24-volt DC power supply, which takes 120-volt AC from the wall outlet and converts it to 24-volt DC to power the rest of this system. This is the PLC, and it's a Micro 820, and you can see the part number as well as the IP address and subnet that have been set up for it. Here's a table showing how all of the input and output terminals have been wired to the physical devices. These are the three input terminals that have been wired to the push button switches, and here are the output terminals and how they've been wired to the different lights. Let me direct your attention to this one specifically. The Micro 820 PLC didn't have enough output terminals to wire a separate output to each light. So we wired two lights to the same terminal, the First Street green light and its associated pedestrian light. But that's okay, we wanted to turn them both on at the same time anyway. So if we were to energize output 2, both of those lights would go on because they're both wired to that output. Same with output number 6. The Main Street green light and its associated pedestrian light are both wired to the same output. So here I am in Connected Components Workbench, and you'll notice that the controller I chose was not the simulated Micro 850, but rather the Micro 820. Here's the part number for it. And if I go to the Ethernet configuration for this PLC, you'll see that I selected this box to configure the IP address, and this is the address I set for it. Now make sure you type this address and this subnet correct so it doesn't override the existing IP address that's been set on that PLC. If I go to the Global Variables section, you can see I really haven't created any new global variables, but I have put an alias near some of the input and output terminals of my PLC so that while I'm writing a program, I don't have to remember which output or input terminal was wired to each physical device. I've got an alias that I can refer to. Now let's go to the program. It's a ladder logic program, consists only of 4 rungs. It's pretty simple. You can see when I push the Start button, which is wired to digital input 0, I'll get continuity, which will energize output number 1 and output number 4, which are wired to the red lights. When I push the Car on First Street button, which is wired to digital input number 2, I'll get continuity, which will energize output number 2, which is wired to the First Street green light. And if you remember, that output is also wired to the associated pedestrian light as well. Same with this Car on Main Street button. When that button is pushed, I'll get continuity, and it'll energize output number 6, which is wired to the Main Street green light, and, as we talked about, the associated pedestrian light because they're both wired to the same output. And on this 4th rung, you'll notice that I've used reverse contacts, indicating that when none of these buttons are pushed, then I will get continuity, which will energize output 3 and 5 and turn on the 2 yellow lights. So now that I have this program written, I'm ready to set up the communication with the PLC. And there's 3 things I need to make sure to do before I download this program. First, double check under your PLC in the Ethernet settings that you've configured the IP address and the subnet mask correctly. Second, we need to give a static IP address to the Ethernet port on your laptop. And the way you do that is you just go to this Internet icon on the bottom of your Windows screen, right-click, open the Network and Internet Settings, and under Ethernet, let's open the Network and Sharing Center. This is my Ethernet that's connected to the BYU-I network, but this is the Ethernet port that I'll be connecting to the PLC. So let's click on this one, and under Properties, I will see this Internet Protocol version 4. Let's open the properties of that one. And by default, it's probably set to obtain an IP address automatically. So you should choose this option to use this IP address. And so that Ethernet port on your laptop will now have this IP address and this subnet mask. Once you've set that, you close out these windows. Now let's make sure that we really can communicate with that PLC. We'll go to RS Links, and if we click RS Who, you can see this is the driver that we created in the previous assignment that's connecting with the loopback Ethernet address. And this is a new driver that I've created that is connected to this PLC, this Micro 820, at that Ethernet address. The way I created this driver was the same as you did when you connected this driver. I'll show you how to do that if you don't remember. It's this tool here to configure a driver. And we selected Ethernet IP driver, Add New. And it created this new driver. And you can see that this new driver has this 192.168.5.102, which is the Ethernet address that we've set for our laptop's Ethernet port. You'll notice it's very similar to the Ethernet address that we've set for the PLC. The only difference is in these last three digits. The Ethernet address for the PLC is 192.168.5.100, and the Ethernet address for our Ethernet port on our laptop we're setting as 192.168.5.102. And in order for Ethernet to connect with a PLC, the first 6 digits have to be the same. So that's why we've made these Ethernet addresses so similar to one another. And once we're sure that we have connection, now we can go to our Connected Components workbench and download the program. I can either download it here with this button, or I can go to this controller here and right-click and choose to download, or when I have the controller open, I can use this button here. It's the exact same function. I'll choose to download with project values. Now if you pop up a window that says it can't connect, just hit retry, and when you select retry, it'll open up a window that looks very similar to the RS Links window that'll allow you to click on that Ethernet driver and select the correct device to communicate to. I'll now go ahead and just download with project values. Looks like my download succeeded. My program is now on the PLC, and I can change the controller to remote run so that the PLC is in run mode. You'll see here that because I'm not pushing any buttons, I have continuity on this 4th rung, so my 2 yellow lights should be on. So let's take a look at the actual electrical panel and see. Here's the actual electrical panel running our PLC program, and the yellow lights are on. When I push the green button, the red lights come on. When I release the button, the red lights turn back off. When I push this blue button, the green and pedestrian light goes on, and when I release the button, they go off. When I push this blue button, the other green and pedestrian light goes on, just like we programmed it to do.